Differentiability. To understand differentiability, we will compare the two functions y equals x squared, which is blue, and y equals the absolute value of x, which is red. Each of these functions has the turning point 0, 0. For the function f of x equals x squared, the derivative of any function is the limit of f of x plus h minus f of x all over h as h approaches 0. For this blue function, f of x equals x squared, the f prime, meaning the derivative, is the limit as h approaches 0. The given function with x plus h in place of x. Instead of x squared, it's x plus h squared, minus f of x means simply the given function, so the derivative of the blue function is the limit as h approaches 0. Squaring x plus h, the green, it's x squared plus 2xh plus h squared. We still have the minus x squared, that blue, all over h. So the derivative of the blue function is the limit as h approaches 0 of 2xh plus h squared all over h, because we have x squared minus x squared. F prime of x equals the limit as h approaches 0 of 2x plus h. 2xh divided by h is 2x, and h squared divided by h is h. And the limit as h approaches 0 is 2x. Because h is approaching 0. This means the derivative anywhere on this blue path is 2 times x. For example, if you pick the point 2, 4, which is on this blue graph, the derivative at that point is 2 times x using this x. So about over here, if we make a tangent line at the point 2, 4, it would be a line with slope 4. The derivative at negative 3 would be 2 times negative 3. Meaning if we go over to negative 3 on this graph, where x is negative 3, make a tangent line at that point, it would have the tangent line where x is negative 3 would have a slope negative 6. And the derivative of this blue graph at 0 would be, right here, f prime of 0 is 2 times 0. Meaning, if we make a tangent line where x is 0, right here, green, the tangent line has slope 0. When I say the tangent line has slope 0, when x equals 0, I mean the derivative is 0 at x equals 0. On the red graph, here's what's different. If f of x equals the absolute value of x, This is two linear things that come together at 0, 0. So the derivative is in pieces. This side of the function is linear line with slope -1. When I say the slope is -1, I mean the derivative is -1. That's for all the x's less than 0. From here this way. But the rest of this absolute value function is linear. That means it's a line with slope +1. That's for all the x's that are greater than 0. That means from this way over, the slope or the derivative is 1. And for this function, we say the derivative right at 0 does not exist because a tiny bit to the left of 0, tiny bit, the slope is -1. Tiny bit to the right of 0, the slope is +1. Because those are totally different, the derivative at 0 does not exist. Here's how we write that officially. Because the limit of f prime, that means the derivative, as x approaches 0 from the left, that would be -1, and the limit of f prime, the limit of the derivative, as x approaches 0 from the right, that would be +1. Those are not equal. Saying the derivative at 0 does not exist is the same as saying the function, which is the red function, is not differentiable. At this number that's in the parentheses right here, at x equals 0. Not differentiable means it is not possible to find the derivative. I'll repeat, it's because the derivative a little to the left of 0 is -1. The derivative a tiny bit to the right of 0 is +1, and those are different. So the parabola is different because we say the derivative at 0 is 0 here, because if we move a little to the left or right of 0, the slope of the tangent line will be really close to 0. I'll repeat, just move a little to the left of 0 and make a tangent line. It will be almost horizontal. That means slope 0. Move a little to the right of 0 on this blue curve and make a tangent line. You'll have a tangent line that is almost horizontal. So for this function that turns at 0, 0, the derivative there is 0. That's for the f of x equals x squared. For the function f of x equals the absolute value of x, the derivative is non-existent at 0. But to the left of 0, the derivative is -1. To the right of 0, the derivative is 1. So this happens anytime a function has something that we call a sharp turn. The absolute value function, we say it has a sharp turn at 0, 0. When a function has a sharp turn, we say there's no derivative at the turn. We say not differentiable at the sharp turn. If the function has a smooth turn, smooth, we say the derivative there is 0. So there is a derivative.